So chapter 17 is all about definite integrals, so actual evaluating integrals. The first section is actually pretty straightforward. Um, but basically, you just want to think of a definite integral. First of all, it has to be a continuous function. It's just going from A to B. We do the antiderivative from A to B. We take the top value minus the bottom value. Very straightforward. A couple of properties that are important. If you switch from A to B and go instead from B to A, it's just the opposite integral value. Anytime there's a constant times a function, you can just move that constant out in front of the integral. This one's going to be pretty important. This is just your additivity rule. Think of it this way. If you're going from A to C, you have any area here, and we cut this. If we go from A to B, then we go from B to C. Really, it's just going from A to C. So these are where it's separated, and it just shows the same thing. Basically, if this is plus and this diagonal matches, you just squish it together to go from A to C. So a lot of this is just what we've been doing. So this is just getting into the actual evaluating now. All right, so we'll just use our power rule. This first one's just a polynomial. So we will add 1 and divide, add 1 and divide. Constant, we just put in the x, and we're going to go from 1 to 2. All right, so I would just rewrite this as 2x squared. We plug in the top in for each x. So 2 to the 4th is 16 fourths, minus 2 squared is 4 times 2 is 8, plus 10. And it's really important because we're subtracting. We have to have this first quantity, then we're going to subtract when we plug in 1. So using parentheses for our subtraction. All right, then we have 1/4 minus 2 plus 5. Okay, so this is just 4. So 4 minus 8, negative 4, plus 10 is 6. Minus, this is going to be 3 1/4. So that'll be 2 3/4. So it's just a matter of kind of working through the math. All right, let me shrink this part up a little bit. Letter B. So remember, whenever you've got the radical, you want to think of that as 2x to the 1/2. So when we add 1, we get 3/2. When we divide by 3/2, we multiply by 2/3. Plus anything over x, this is 3 ln x from 1 to 4. So when it's a definite integral, we don't need the plus c. We're evaluating for the specific interval. All right, so I'm just going to rewrite this as 4/3. And what we might want to do is take that 3/2 and make that square root of x to the 3rd. It'll be easier to evaluate. Plus 3 ln x from 1 to 4. All right, so when I plug 4 in, the square root of 4 is 2. 2 to the 3rd is 8 times 4 is 32 thirds, plus 3 ln 4 minus Now plug in 1. 1 to any root or exponent is just 1. Times 4/3 is 4/3. When we plug ln1 in, this is really important. ln1, all logarithms, your basic logarithm crosses at 1, 0. So ln of 1 is 0. That's something that's just really good to know. So this whole thing is 0. So I can take 32/3 minus 4/3, which is 28/3, plus 3 ln 4. Okay. All right, I'm going to shrink all of that. Making room for letter C. All right, antiderivative of sine, negative cosine. Then we have to divide out the 2. So really negative 1/2 cosine from 0 to pi over 3. When we plug pi over 3 in, that's 2 pi over 3 minus negative 1/2 cosine 2 times 0 is just 0. Now about the evaluating. All right, so let me do the easy one first. Be very careful about cosine of 0 because cosine starts at the top. Cosine of 0 is 1. So this whole thing, I'm going to distribute that negative, is just 1/2 because we have a half times 1, which is 1/2. Now, 2 pi over 3, we have to use triangles. All right, 2 pi over 3 is over here. This is where this is 2 pi over 3. This is pi over 3. Pi over 3 is 60 degrees. So this is our 1, 2 square root of 3 triangle. Let me kind of blow this up a little. If this is 60, this is 30. So across from 30 is 1. Hypotenuse is always 2. Square root of 3. Okay. Now, the other important thing is, if we start at the origin, when we go to the left, the x value is negative, y is positive, and r is always positive. So cosine of this triangle is adjacent over hypotenuse, or x over r, negative 1/2. So I'm going to bring down the negative 1/2. Times 1/2 is 1/4 plus 1/2, which is 3/4. So that took up a whole lot more space. Sorry about that. The next one actually takes hardly any space. All right, so we're going to use our graphing calculator. This is slick. So if you can use, if this is a calculator problem, please, please, please use it. All right, so because there's no way to find that antiderivative with what we know right now, you'll learn this in Calc 2 for those that move on. But when you're evaluating integrals, Math 9, you will see this pop up. Plug everything into the right spot, and you should get 586.3. This spelled out specifically for sig figs, so I needed 4 digits, and that is lesson A.